Hi guys, very good morning. This is Dr. Sajja Suneel from Data Science Department. Today I am here to discuss you about Introduction to Internet of Things, and today's class is purely a revision for the things which we discussed so far from the past different classes. And in today's class I am going to revise the module 1, which is Introduction to Internet of Things. In this we'll divide the session into two different parts, guys. Now, from these two different parts, you are knowing the entire things of internet and how these things has been designed, and you guys are knowing in detail about what are the different kinds of internet of things, physical devices, and what are the physical design of IoT, logical design of IoT, and what are the different kinds of smart appliances which are used, and what are the different kinds of IoT levels, level 1, level 2, level 3, level 4, level 5, level 6, and like this you guys are knowing all those things in detail. And along with that, we'll start revising the things which are related to Introduction to Internet of Things. This is part 1, and in the next class I will discuss about part 2, where it was a continuation for the things which we are going to discuss in this particular course called Principles of Internet of Things. In this, the first module is purely based on this Introduction to Internet of Things, where you guys are knowing about multiple things, such as the module 1 is having a outline which is Introduction to Internet of Things. In this, these are the specific topics which we are going to revise in today's session. Those are Introduction to Internet of Things, what exactly IoT definition was, and what are the characteristics of IoT, and how physical design of IoT, and how logical design of IoT, and what are the different types of IoT communication models which we have, and also what are the different types of IoT communications which are enabled technologies, and what are the wireless sensor networks, what cloud computing, what big data was, and what embedded systems are, and what are the communication protocols, and what are the different kinds of IoT levels along with the templates, and also domain specific IoT, home, city, environment, energy, retail. All these things are going to be discussed in today's class as well as in the coming class also. This session is divided into two parts, so concentrate on these two parts so that you will come to know what exactly this Internet of Things was. So start with discussing about what Internet of Things are. What are the objectives and what are the outcomes which are going to be achieved by us and which are framed to know about this Introduction to Internet of Things was? First, the main objective of this particular module was you guys are going to understand the concepts and characteristics of Internet of Things. That was the first thing which you are going to learn. And the second objective which is aimed for, we need to familiarize what are the different kinds of IoT protocols and what are the different kinds of communication models which are used to communicate between the IoT physical devices and endpoints, and what is the API which is designed to communicate with the devices. API stands for Application Programming Interface, and also we need to know how to explore the IoT enabled technologies along with their application with different domains actually. And what are the outcomes which are going to be achieved by us after completion of this particular session. And the session after completion of knowing about this Introduction to Internet of Things, you guys are able to define what exactly IoT was and what are the different types of characteristics which are going to be there, and you guys are able to understand different types of communication protocols and different types of communication models which are existed in IoT, and you guys are able to identify and analyze the domain specific IoT applications. These are the things which are the outcomes of this particular topic of this class today. And have a look what IoT was. IoT comprise the things which have unique identities and are connected to the internet. Any kind of object, any kind of thing which is existed in the network, existed in the system, is going to be connected with a network called internet. That is what existing. There are n number of devices and network computers which are 5G enabled mobiles, which are having unique IP addresses and also connected to URL. For suppose, take our smart gadget which is with us in our day-to-day life. By using this smart gadget which is having an unique IP address which is MAC address, and this particular smart gadget is connected to internet. True or false? Without internet, can't we imagine? Are we going to communicate with someone else? Without connectivity, is it possible to transfer a text message through WhatsApp? No, right? That is how the things are going to be happen. Along with it, there are n number of systems which are very helpful in IoT systems. You can use any kind of system by using these particular things. Here, a small images are going to be shown to you for your better understanding. We are going to control any hardware device or any kind of devices which are connected with the help of internet via IoT. There are n number of sensors which are placed automatically to make the function of those particular devices. The devices such as thermostats, utility meter, Bluetooth connected headsets, irrigation pumps, and also electrical cars. These are the things which are very helpful. And first, whenever we are discussing about Internet of Things, we need to discuss about the father of IoT, who is Kevin Ashton, who is a person who started discussing about this particular technology in first. He is Kevin Ashton. In 1999, he was the first person who wrote Internet of Things as a title on a PowerPoint presentation. When he is working as a protector and gamble, he had come with the ideas attaching RFID chips to consumer goods to automatically track the stock levels in stores. He was the first person who has used the IoT, right? And coming to the components in any kind of smart systems in Internet of Things, it is driven by the combination of sensors, connectivity, and peoples and process. These are the three components which exist in IoT. And coming to the advantages, there are some advantages as well as disadvantages in Internet of Things. The first advantage was we need to minimize the human effort. As there are n number of devices, the IoT is going to communicate with each other and also do a lot of tasks for us. Then automatically our human effort is going to be minimized. For example, take home automation by using IoT. The entire things which are existed in your home is going to be monitored with the help of a smart gadget which is holded by your hand. If you are having an internet connectivity between this particular mobile gadget to your home automation network, and we are going to save the time and it is going to reduce the human efforts. Time is the primary factor which can be saved by this IoT platform. That was the best example. Have a look towards this home automation system, how the things are attached in this system. And also, it is going to enhance the data collection. For suppose, by using these IoT applications, raw data is going to be gathered, and based on that raw data, it is going to be analyzed and we are going to produce and we are going to take some decision making. Here, the image which I was showing, by wearing some wearable devices, a patient health is going to be continuously monitored. If he required any kind of emergency services, automatically this smart device is alerting the nearest hospitals as well as the ambulance team as well as the health centers, so that automatically we can save the people health also. And what are the disadvantages? Security was the main disadvantage. Why? Because in IoT system it was interconnected where people are communicating through the network. So there are a lot of security measures, which kinds of network attacks. And coming to privacy, even with the active participation of the user also, IoT system provides substantial personal data in maximum detail. Coming to the next one, complexity, the design and the development and the maintenance. HR plays a very important factor in the large technology of IoT, which is quite complicated. That's why it is complex. What are the different kinds of applications which are presented in IoT? As I told you, there are n number of applications. You can name it. You will always have it in IoT industry. That's why I kept this particular title. You name it, you'll have it on IoT. That I can show you with 100% assurance. See some of the applications which I have narrated here. The first one is your smart cities. What smart cities will consist of? There will be smart homes, smart buildings, urban computing, traffic monitoring, security emergencies. And coming to commercial, shopping system, which is retail system. Coming to industry, smart grid, smart meterings. Coming to infrastructure, real-time performance, energy efficiency. Coming to healthcare, smart wearables, personal remote health system. Coming to environment, smart farming, smart agriculture, wild vegetations, climate change monitoring. All these factors will come under IoT applications only. Now I will see a little bit in thoroughly. What was the future scope for this our IoT was? IoT in today's industry, it gains a lot of popularity in lesser time. And also there are a lot of advancements which are happening in our IoT industry, such as artificial intelligence, machine learning, deep learning, and all these can be utilized and make our industry more effectively by improving the automation. And by using these AI, AML programs, by combining with IoT industry, a proper automation setup has been extended. I can say you one thing guys, change is the only permanent thing in the world. The sky is the limit. It's only beginning for IoT. That I can promise you. Why? Because in future, we'll see everything in IoT systems only. No more paperwork, no more hard work. Everything will be taken care of IoT devices with a lot of advancements which are happening in the current industry. That's why I have written this particular tag also. Change is the only thing which is permanent in world. The sky is not the limit. It's just only the beginning for IoT, guys. Have a look. What are the different characteristics which are there in IoT? The first one is connectivity. There are n number of devices which are connected with Bluetooth, Wi-Fi, cellular, and LAN. All these are the things which are makes the devices connectivity to each other and transfer the data. And the next one is sensing and data collection. IoT devices are equipped with the sensors to gather the data from the surroundings. And these sensors can be utilized by calculating the temperature, humidity, light, motion, pressure, etc., etc. And coming to data processing analytics, IoT systems are going to process and analyze the data which is collected to extract the valuable insights. And also there are a lot of advanced analysis techniques which are used with the help of machine learning and artificial intelligence, guys. And coming to the next one, remote monitoring control. By using this remote monitoring control, IoT is enabling us to monitor and control the devices and process the things in a easiest way. Automation and decision making, which makes us enable to automate the processes, and also it makes us intelligent by decision making based on the real-time data. Devices can autonomously perform the task, adjust the settings. It triggers the action based on the predefined rules and algorithms which are used by us. Coming to the best example, machine learning algorithms. And coming to the scalability and interoperability, these plays a very important role. Why? Because IoT solutions are designed to be scalable, and which allows us for the deployment of large-scale networks through the interconnected networks, which improves the interoperability standards and also the protocols, which sees the seamless communication between the integration of heterogeneous devices and system, guys. And security and privacy, which plays a crucial consideration in IoT deployments. Why? Because these systems has to take various kinds of security measures, including encryption, authentication, access control, and device management, where we have to protect the data by taking integrity and confidentiality of communications. Diverse applications. IoT find n number of applications across various domains, which include smart homes, health, agriculture, manufacturing, transportation, and lot more things which are where we are having diverse of applications, guys. And coming to characteristics, I already told you, along with the past characteristics like connectivity, sensing, data processing, automation, scalability, security, and diverse applications. Along with this, there are n number of things which are reshaping in industry, driving information and enabling the development more smarter by connecting to the ecosystem, such as dynamic and self-adapting. Automatically the cameras are sensing the detection. Automatically those are habituated. For suppose, take your smartphone, and what the old generation will do with smartphone. They are also being self-adapted, right? Like that, our IoT devices are also dynamic and self-adapted and self-configuring. Our devices are going to have an update automatically with your minimal support. The device is going to configure by itself. And interoperable communication. There are n number of communication protocols which are utilized, which are going to be shown to you in the next slide. And unique identity. Every device is having a unique IP address. Integrated information network. There are n number of things which are performed by basing on these particular factors. Have a look, guys. Physical design of IoT. The thing in IoT, which refers IoT devices, which have unique identities where it can perform remote sensing, actuation, monitoring, as well as the capabilities. IoT device, simple way, exchanging of data with other connected devices and application. Either it will be direct or indirect. And also, it is going to collect other devices and process the data locally. And there are other definitions also. Have a look, send the data to centralized and cloud-based backups and performs tasks locally or other tasks with the IoT infrastructure based on temporal and space constraints. These are the things what physical IoT was. This was the generic block diagram of an IoT device. Have a look. We are having connectivity, processors, audio, videos, I/O interfaces, memory interfaces, graphic interfaces, storage interfaces, and this is Arduino board. Arduino board. Here, if you observe, these are general purpose pins, Ethernet port, USB ports, audio jack, camera, HDMI, micro USB, micro SD card, where we are utilizing in Arduino board. This was the generic block diagram, static representation for IoT devices. If you observe IIO devices, where we are having UART, SPI, I2C, CAN, and coming to audio video, HDMI, 3.5M, RCA, storage, SD, MMC, SDIO, graphics, GPU, processor, CPU, connectivity, USB, RJ45, memory interfaces, NAND, DDR1, 2, 3, 4, whatever you can utilize. And coming to IoT protocols, in IoT protocols, which are going to help us to establish the connection between the IoT device and the cloud-based server over internet. And these protocols are going to help us to send commands to IoT device and receive the data from IoT device through the internet. What are the things which are existed in these IoT protocols? There are 4 different layers: application layer, transport layer, network layer, link layer. Coming to application layer, HTTP, CoAP, WebSockets, MQTT, XMPP, DDS, AMQP, message queue telemetry transport, advanced message queue telemetry transport, constraint application protocol, hypertext transfer protocol, extended markable protocol, DDS, data definition system. Like this, multiple things are there. Transport layer, only 2 protocols: TCP, UDP, transaction control protocol, user datagram protocol. Network layer, IP version 4, IP version 6, and 6 low wireless PAN network. And coming to link layer, there is Ethernet, Wi-Fi, cellular, Wi-Fi, and WiMAX and WPAN. These are the IoT protocols which are existed. And coming to the logical design, if you observe on the screen, there was a diagram which is represented in a good way, such as applications, management, service, security, communication, and device. These are the things which are shown to you for a better logical design purpose. And this logical design is going to refer an abstract representation of the entities which are processing without going to the low level specification at the time of implementation, guys. And any kind of IoT system which comprises a number of functional blocks which provides the system capabilities such as identification, sensing, acquisition, communication, and management purposes. These are the 6 functional blocks which are existed in logical design of IoT. And these are the functional blocks. Device is going to sense, accommodate, monitor, control the functions. That's what a device will do. Communication block, which is going to establish connection for an IoT system. Services, where device is going to be monitored, device is going to control, device is going to publish. Management, where we are providing functions to govern IoT system. Security, we are going to secure a priority function by authenticating, by giving authorization, by checking the messages, by checking the context integrity, by checking the data security. Applications, and these applications are going to act as an interface where the users are going to control and monitor various aspects of IoT system. This is how the functional blocks are. And coming to communication models, there are 4 different types of models: request and response model, publish and subscribe model, push and pull model, and exclusive pair model. These are the 4 different types of communication models which are existed. And coming to IoT enabled technologies. In IoT enabled technologies, there are wireless sensor networks, cloud computing, big data analytics, embedded systems, security protocols, and architectures which are existed along with the search engines. WSN, wireless sensor network, cloud computing, big data analytics. These are the 3 different kinds of enabled technologies are in current industry. Coming to cloud computing, which is an on-demand availability of computing resources, especially for data storage purposes and for computing power without direct interaction with the cloud service provider. And in this service models, there are reference models which are utilized by the cloud computing, And these are categorized into three different kinds of services such as IaaS, infrastructure as a service, PaaS, platform as a service, SaaS, software as a service, IaaS, PaaS, SaaS. These are the three different kinds of service models which are listed as on the screen. These are the three basic service models which are listed, and these are the service models. So for this, I'll show you with a small example how IaaS will function, PaaS will function, SaaS will function. If you observe, IaaS only virtualization, server, storage, networking, which is managed by vendor. The remaining you are going to manage, such as data, application, runtime, middleware, OS. And coming to PaaS, we are only managing data and applications. The remaining all are going to be managed by the platform, the runtime, the middleware, the operating system, the virtualization, the servers, the storage, the network. Everything is managed by the vendor only. And coming to SaaS, where software as a service, here everything will be managed by the vendor except the data. What you want, you just specify. Everything is going to be delivered by the software as a system. This is how the things are going to be existed by using these services. I'll take an example. You guys are preparing a pizza. For that, how the things are. Have a look. Made at home. This is what you will do when you are preparing at home. Right? Take and bake, which is the best example for infrastructure as a service. Dining table, soda, electrical gas, oven, fire, which is managed by you. Pizza dough, tomato sauce, topping, cheese, which is managed by vendor. This is infrastructure as a service. And coming to the next one, data, dining table. The next one, soda, which is managed by you. The remaining things, electrical gas, oven, fire, pizza dough, tomato sauce, topping, cheese, which is managed by vendor. This is how pizza is going to be delivered, which is platform as a service. In simple words, infrastructure as a service, take and bake. Platform as a service, pizza delivered. Software as a service, dined out. No need to take care of dining table. Everything will be provided by the concerned person. When we went out for a restaurant, that is software as a service. Everything will be taken care by vendor except the data. Where for which hotel we have to go. That is how the things are. And big data analytics. One thing I will tell you, big data, which is a collection of data set whose volumes and velocity and varieties are so large, it is very difficult to store the things, to manage the things, to process and analyze the data using traditional databases and data processing. And I will tell you one thing, guys. Big data analytics, which involves several steps starting from data cleaning, data munging, which is data wrangling, and data processing and data visualization, guys. And by using this analytics, it is used to extract the meaningful insights and also to extract the hidden patterns, unknown correlations, and market trends and customer preferences, guys. This is how big data analytics is going to be. Coming to embedded system. Embedded system is a computer system where we are having computer hardware, softwares which are embedded to perform specific tasks. There are key components of embedded systems like microprocessor, microcontroller, memories which are related to RAM, ROM, caching, and network units which are Ethernet, Wi-Fi, adapters, input and output devices like keyboard, monitor display, mouses, all these things, all the other stuff, and storage devices like flash memory. And there are specialized processors such as DSPs, digital signal processing, and graphic processing, ASPs, which is application specific process. And this embedded system range from low cost miniature devices such as digital watches to devices such as digital cameras, POS terminals, vending machines, application. All these factors comes under embedded system only. With this, I can conclude the basic introduction to Internet of Things, and the next part will be continued in my next class to know more about in detail about this Internet of Things. Thank you, guys.
Like, share and subscribe. Hit the bell icon for more updates.